Now, with the information we just discussed on the last example, and that we know if we get a quantity squared equals a number, we can get in there and solve for our variable, whatever that might be. We can get in there and use our square root property to solve for the unknown. We're going to work toward that, and we're going to learn about our next method to solve quadratic equations, and that is by completing the square. Now, to do so, we need to look at some special types of trinomials called perfect square trinomials. All right, here's a few examples. First of all, let's look at this one. X squared plus 10x plus 25. We call that a perfect square trinomial only because of the way that it factors. Okay? Also factors unfoils. Here, first times first will be x here and an x here. The two numbers that multiply together to give us the 25, but combine together to give us the 10. You might be thinking positive 5 and positive 5. You can pause here and mentally FOIL that out to make sure we factored that correctly. And if you have x plus 5 times the exact same thing, x plus 5, you can write that as x plus 5 quantity squared. Aha! That's what we're talking about over here. That's what we want to create. Here's another example of a perfect square trinomial. X squared minus 6x plus 9. It's a perfect square trinomial because of the way that it factors. This thing will factor into x minus 3 times x minus 3. If you want to pause and FOIL that out, you sure can. We're going to then write that as x minus 3 quantity squared. All right, good. Here's another one that's not so pretty, but is still a perfect square trinomial. How about an x squared plus 3x plus, I don't know, 9/4. Yeah, I do know, okay, because I know the trick on how to create these perfect square trinomials. Let's see how this thing factors. Well, we need an x here and an x here, so that x times x gives us the x squared. Now we're looking for the two numbers that multiply together to give us 9/4, but combine together to give us 3. That's going to involve a fraction. So the two numbers that multiply together to give us 9/4, but add together to give us 3, are going to be 3 halves and 3 halves. That's equivalent to 1.5, right? Okay, so you can see why they would add together. 1.5x and 1.5x will give us the 3x. And then last times last, the 3 halves times the 3 halves would give us the 9/4. So I know that's a little bit ugly, but sometimes you are going to have to deal with those fractions. We will then write this as x plus 3 halves quantity squared. Okay? So they talk about some more about perfect square trinomials. How though, what makes these be a perfect square trinomial is this is a special number right here that makes it factor all nice and neat. Okay? For example, that number 25 is what makes this be a perfect square trinomial versus, let me write it over here, if you had x squared plus 10x plus something else, like let's say 24, that's not a perfect square trinomial. Even though this thing factors, the two numbers that multiply together to give us 24, but add together to give us 10 are 6 and 4. And you see how this is not the same factor as this. It's not a perfect square trinomial because we can't write that as a square. So we're headed to find this magic number that makes us have perfect square trinomials. That is what's called completing the square. Okay? There are 2 steps to do this. Now they tell you to find the magic number in. You take half of the coefficient of b, and the coefficient of the linear term, the x term is the b, and then you square it. So to find the 25, what we do is we take the b term, which is the 10 in this case, and take half of that to give us 5, and then step 2 is square it. 5 squared is 25, and that's how we get that magic number we needed. Now, I knew that trick back on my other example on the previous page. How did I get that 9/4 right here? How in the world did I know that that would work? Well, all we have is the x squared plus 3x, and I'm looking for the 9/4 to make that be a perfect square trinomial. So the first step is you take the coefficient of the x and take half of that. That gives you 3 halves, and then you square it. So 3 squared is 9, and 2 squared is 4. That's how I knew to put a 9/4 here to create that perfect square trinomial. So, oops, I went too far. So on our examples down here, we're looking for the number n that's going to create the perfect square trinomial. Okay? So the b term here is 22, and so we're going to take half of 22. That gives us 11. That's step 1. Step 2 is to square it. So the n value should be 121. Now you can check to see what we're doing here by saying, does y squared plus 22y plus 121 factor all nice and neat? Is 121 our magic number? Yes, it would be, because this factors into y plus 11 times y plus 11. We would write that next as y plus 11 quantity squared. Okay, so our answer here, what they're asking you for is what's the value of n? In that case, it's 121. On this next example, we have v squared minus 11v plus what is going to make that be a perfect square trinomial? Okay, the b value here is a negative 11. Step 1, take half of that. I would go ahead and just leave it as a fraction. Okay, instead of writing as a decimal or a mixed number, just leave it as an improper fraction. So step 1 is to take half of that. Taking half of something is the same thing as dividing by 2. Then step 2 is to square that. So negative 11 squared is going to be positive 121 over 2 squared is 4. You square the top and square the bottom is how we square a fraction. So that is the thing that's going to make this factor all nice and neat on number 36. On number 38, this time our b value is 2/5, and so we're going to take the 2/5, and instead of saying divided by 2, where I just created an ugly complex fraction right there, taking half of something, you can divide by 2, or you can multiply by a half. That is step 1, taking half of 2/5. Now, the 2's will reduce here. Half of 2/5 is 1/5. That's step 1. Step 2 is to square that. And so my n value for number 38 that would create a perfect square trinomial is 1 squared over 5 squared. So 1/25 is the value of n. That's going to make the k squared plus 2/5 k plus 1/25. That would factor all nice and neat. See if you can figure out what that would be.